Hello, and welcome to our first episode of Dispatches from the Energy Transition for 2026. In this episode, we're going to be focused on PV module recycling and end-of-life considerations for PV projects. My name is Lucas Miller. I'll be your host today. I'm a senior engineering consultant at Mayfield Renewables. We are an engineering consultancy serving mid-market commercial scale projects nationwide, where we provide owners, engineers services, project consulting, plan set development, feasibility studies, and technical education services. We're joined today by a couple guests, experts in end-of-life, decommissioning, PV recycling, and really going to dive into kind of some best practices for developers, take a deep dive into how PV recycling works. And hopefully you'll come away with this with more knowledge of what's new today, what's possible today, and some ways to maybe change your project development process. So we'll start with some quick introductions. So Brett Henderson, CEO from SPR. I'm going to henceforth refer to you guys as SPR, but for the folks in the audience, that's solar panel recycling. Brett, how are you doing today?
Good, Lucas. Thanks for having me on.
And do you want to do a quick walkthrough, Brett, just kind of your background, your role at SPR, and then more broadly, what SPR does?
Yeah, absolutely. My background has been in the recycling industry, basically my entire career. Right out of graduate school, I had my undergraduate at Ohio State University's Fisher College of Business and went on to get my MBA in management at Cleveland State University. And right out of that field, I went into recycling. Been in this industry for about 17, 18 years now. And really have a heavy focus on not just the circularity side of things, but also building customized solutions in whatever industry we're in. One of the biggest hurdles and challenges with recycling, and I think we'll dive in a little bit today, is how it's not a one size fits all for the client or the generator of that actual material that needs recycled. So it's been a large part of my background is kind of working with a team here at SPR and to kind of think a little bit outside the box. Our parent company is Powerhouse Recycling Incorporated. It's a certified electronics recycler, data destruction, and IT asset management company. We've been in business just short of 2 decades now, based in North Carolina, and it's kind of how SPR was founded. Back in 2018, we had a major utility kind of come to us and say, hey, Brett, we have, I want to say about 10,000 panels farm that's getting completely decommissioned, and we've kind of been looking in the U.S. market. And there really isn't a full recycler at the time, one that is doing more than just aluminum harvesting and, maybe commingling or landfilling the rest. So myself and some other co-founders spent about 5 years of R&D from 2018 to 2023, traveling overseas. The Asian markets, the European markets, they're typically a little bit more ahead and proactive on new waste streams, and learned quite a bit. And in 2023 is when we kind of made the subsidiary company SPR. So it's a little bit about my background and kind of how we fell into this solar recycling space, if you will.
Great. Thanks, Brett. I also want to bring in Justin Wright, Executive VP at RCI Energy Services. Justin, you want to give us a similar rundown?
Sure. Thanks for having me, Lucas. I appreciate it. Yeah, I'm Justin Wright, been in utility space for 22 years now. 13 of that was in nuclear. The majority of that time was in nuclear operations. Then I moved to business process management and then into renewables. The past 9 years I've been in renewables in form or fashion, but mainly solar and battery. I am now the executive vice president here at RCI. We were founded in 2012. Started out as a construction company. Still do the construction services for solar and battery sites, but mainly our focus is on electrical services all across the U.S. We have a nationwide footprint. And then of course, decommissioning is one of our large business lines. So that's me in a nutshell.
Great, thanks. And just one quick follow-up. I think you mentioned this, Justin, but both of you, so SPR, RCI, both of you operate nationwide.
Yeah, absolutely. Yep. We service all 50 states and have source panels and even outside of the US or at least the connecting states as well. So yeah, we're in all markets.
Great. Couple really quick housekeeping pieces and then we'll dive into it. But for anyone who's here and hasn't been on one of our webinars in the past, we really lean into live questions and answers. So we'll have our Q&A tab open throughout. You can find that at the bottom of your screen. It may be under the More tab. We also have a chat open where we will be sharing links throughout. So you can find links to both the RCI and SPR website. We'll have a few more resources for you as we go on. And this whole recording will be shared with everyone after the webinar. So you'll get a copy of this by email and keep an eye out for that in the coming days. But let's dive into it. So to start us off, we're just going to take a look at what is the material that goes into a PV module and what can we do with it? How recyclable actually are these pieces of technology that we're all deploying? So Brett, I'm going to kick it to you and really starting with this chart we see here on the left. If you could kind of walk us through the core materials that go into most solar modules we're seeing on the market today.
Yeah, absolutely. So I think it's first important to note this chart we're looking at is for silicon-based panels. The poly and monocrystalline panels are about 95% of the global market, so that's why there's a heavy focus on it. In the U.S. market, it's closer to about 65% because obviously First Solar is a major player here in the market, which would be a cadmium telluride-based panel. So there'd be some differential here in the materials in it. But again, from this particular graph, we'll focus on those silicon-based models. So one thing that I'm sure many people on this webinar know, regardless of what part of the solar industry they're in, is that a lot of models are substantially different, right? In size, compositions, things of that nature. Junction boxes, how many junction boxes, depths, width. So that's why you'll see a little bit of ranges here. So glass on probably the heaviest panels could be up to about 80% of it. So we put a 70 to 80% range. It's many of the panels might be in the 60 range, but 70, 80% of that's glass. So really, when in the grand scheme of anything recycling, regardless if it's the solar industry or not, you want to look at what makes the major composition of that item. If that's not being cleanly recovered, recycled, and introduced into a new supply chain, then how much are you really recycling, right? So glass is the major portion of a solar panel. Your aluminum frame could be 10 to 15% of that composition. I touched on cadmium telluride earlier. Most First Solar modules don't have any frame on them. Then you have your silicon wafers that will contain, silver, lead, other metals. You have your plastic that will be in your back sheets, and then other trace metals that we kind of have discussed. So, when these are entering our recycling plants throughout the country, our goal is to cleanly separate them. So glass could go back into glass manufacturing, aluminum could go back into aluminum, and vice versa. If they're commingled, then you're generating a product that either is going to ultimately have a lot of waste when that manufacturer consumes it, or won't even be recyclable.
Got it. And I think a lot of people that are in the audience here may be familiar with seeing a few different module types when they're looking at spec sheets, especially monocrystalline, polycrystalline, thin film. So from your perspective as a recycler, Brett, how much difference does it make if I know my site has thin film versus mono versus poly, et cetera?
It makes quite a bit of difference from anywhere from, how Justin's team was probably going to manage the decommissioning side of things, which, I'll let him get into, as well as how many panels could fit on a truck. Transportation is a a major factor in costing. That same transportation that got the panels on site has to get them off site, right? So how many you could fit on a truck, and also some recyclability percentages. There's a lot of variance in it. So knowing the panels you have on site, make, model, count, providing things such as conditions, providing things such as how you access the site to offload them. These are all important factors when, whether it's from the decommissioning or recycling side.
And I know in a little bit, we're going to touch on kind of complete true recycling, right? And really getting the most juice from this squeeze. But looking at how we've broken apart the different core materials here, are any of them, particularly difficult or much easier to recycle than the others? Like what's the biggest challenge as a recycler when you're breaking down a module?
Right. So you could answer that question a few different ways. Let's start with glass, right? Because that's predominantly the major component of it. So glass, in terms of a supply chain, it could be an issue to various recyclers. Not all glass is the same. We do quite a bit of lab testing to understand the composition of it. Certain consumers of it will need specific sizes, specific types of glass and composition. So glass poses problems on the consumability side of it, as well as the technology side of it. So, if us three were to hop into a company tomorrow and we'd had no background on recycling and say we threw these things all through a shredder, you're just making smaller pieces that are commingled with glass and silicon and plastic. So now you just have products where the glass consumers can't use it, the silver consumers can't use it. So that's one of the challenges from the recyclability side, is making sure glass is clean, having proper testing and lab reporting on it, and proper sizing to make it the most marketable product. And then plastic, kind of is a challenge in regardless of what recycling medium you're in now in the United States. There's a lot of issues with getting plastic separated cleanly and into consumers that could do it in a volume that is actually substantial.
And Justin, I want to bring you in as we kind of turn our attention more to the upper right here and some of the figures that were provided here by SPR. And really what we're looking at here is what we refer to as the end of life for our system. At Mayfield, we do a lot of preliminary analysis where we're modeling PV production for what we refer to as the system lifetime, which is usually 25, 30 years in the future. I feel like you hear industry folks refer to these as 30-year assets all the time, but that's kind of like what they can do, but not actually what happens in reality in most cases, where we see it's like around 11 years on average to quote unquote end of life. So now how do you make sense of these numbers, and what do you see as in your experience as a decommissioner?
Yeah, they do get labeled as 30-year assets quite a bit. I do agree with this though. What we're seeing is that 10 to 15-year time frames about that average, but real world operating and maybe financial or regulatory obligations can come along and make that decision even sooner than anticipated. So it doesn't mean that the panels are actually at end of life. They could still be producing electrons. They're just might not financially make sense for whoever that owner is. We've also run into maybe lease situations that are the rooftop lease is no longer valid, so that it needs to be removed, and even dealt with like Department of Environmental Quality before, because a ruling came down to have to move the panels off of the land that it was on. So it can come in many cases. It doesn't necessarily mean that it's going to last 30 years, but mostly our probably the one we're seeing the most now is the repower requests. So that seems to be growing.
Yeah, and maybe if you could speak a little bit more to that, that's also going to be, ironically enough, our dispatches topic for next month. Is we're going to be joined by SMA, Chico Electric, and we're going to talk a lot about repowering. But what are you seeing on your end, Justin? Like, what are the drivers of all of these repowers, maybe earlier than we may have expected?
Yeah, again, it could be maybe the parts like for maybe inverters or something's not there, so they need to do a refresh. Panels just aren't as efficient as they once were. They technology's been rapidly advancing in this space, and I think some of these owners can see they can get more energy density at that footprint, so it can make a decision that way, especially off of the on the financial side. It just doesn't really pencil out sometimes if they're not producing the way they once were.
And to kind of expand on that a bit, obviously on the residential side, these systems are going to be designed to provide the power needed for the home. And those residents are looking to hopefully that panel to go 30 years, if not longer, right, outside of a weather event or some sort of failure. So but these type of stats that you're seeing, we have 3 operating facilities. We'll get into them later: Texas, Georgia, in North Carolina, servicing the country at the moment, and we're collecting from just about every state. The 11-year timeline is because a lot of the volume that's really making the averages and the numbers are going to be coming from the commercial, right, side of things, the utility, the large energy companies. And there's been a myriad of reasons why they hit end of life soon, right? You might have a weather event. We've had panels that have been in operation for less than a year that we've had to recycle. You might have the repowers is what's really kind of driving the numbers as well, right? We've had a lot of talk at the with some major energy and utilities when the Big Beautiful Bill Act went in, and some of the incentives are going to be ending, or sunsetting, 2030. Well, maybe they're going to move up their repower timeline now to try to capture some of that. So there's a lot that goes into that, right? You have a farm of 200 or 300 watt panels, and you can go to market with 600, 700, 800 watt panels. That it's something that's considered on the business side of things. But obviously on the residential side, that goal is for it to go as far as it can.
Yeah, I think that's an important distinction, Brett. Like the scale of projects really may have some impacts here. And Mayfield's focused on commercial projects. From what we've seen for repowers, I think this 11-year figure is about right. Most inverters have a 10 to 15-year warranty period. So for us, it very much falls in line with that lifespan rather than the lifespan of the PV module, which could be much longer.
Right.
But I think for the purposes of our conversation, we may use the term end of life for the rest of the hour. And just for the audience to know, we don't mean 30 years necessarily. We mean when the system life is over, when we're decommissioning. And Justin, maybe I'll open this up to both of you guys, but as we kind of move forward here, could you just recap for us what is typical in a decommissioning process today? How I know at RCI, you guys are recycling everything or almost everything on every project, but broadly speaking, what are you seeing within the industry? Like, is this baked into the process, or does a lot end up in the landfill still?
For the landfill part, we don't put anything in the landfill. Not to say that doesn't happen, but most of our requests come from like IPPs or large utilities. So they have, policies in place to not put this stuff in landfills, obviously. But we don't do that on our side. Brett, I don't know if you want to speak to that at all.
Yeah, so we source panels of all volume from myriad of asset owners. So I think overall, if you look at all the panels in the United States, a vast majority still are ending up in landfill as the cheaper option. But Justin's completely right. The utilities of the world and the large IPPs that recognize, hey, maybe in my given locality or state, and I know we're going to talk regulations later in the hour, but maybe in this state I can still legally landfill them, but there's a lot of other inherent risks to that, right? If a lot of the opponents in the solar world will they don't even think they're recyclable, which is obviously false, but B, they really like to kind of point out that there's a lot of incentives and clean energy initiatives just to find out that they're filling local landfills with items that have metals in them. So unfortunately, a large portion is going into landfill, but we've seen a big shift the last 2, 3 years in the education of options out there, and a lot of the major players in the industry that are not doing that ahead of being forced to recycle. These are the thought leaders in the industry. So you start seeing some of the smaller to medium-sized asset owners saying, okay, if they're pre-planning for this and they have a process in place, we need to follow suit.
We just got a great question from Donnie in the audience, Brett, and I'll turn this one to you. But Donnie asks, are manufacturers thinking about, or have you talked with them about making modules more easily recyclable, or to in general bring the cost down of recycling?
Yeah, absolutely. I mean, we could probably speak a whole hour on manufacturers and recycling, whether in the solar space or really any manufacturer, and what some might view their responsibility in this, or maybe not having their responsibility. But yeah, the U.S. manufacturers and even many solar manufacturers overseas, this is something that they have, whether it's a an entire group within the organization or even a collection point to get it to recyclers. They are recycling. They recycle a lot of their breakage even in their manufacturing lines. But the harder part of that question, and the deeper part that I kind of joke that you could spend an hour plus on, is making them more recyclable, right? This has been an issue in the electronics recycling world for the longest time. Apple's one of the most powerful companies in the world, and just about every household has probably an Apple product in the United States. And they've had a lot of pressure over the years to make things more recyclable. There's a ton of little screws in it, and there's adhesives. Well, solar has a lot of focuses too. They got to meet with demand. They have to withstand 30 years. In the field is the goal, weather element. So a lot of manufacturers might not be prioritizing that as high as other, kind of market demands on making them more recyclable. There's a lot of research coming out of the EU of attempts to do so, and I think manufacturers have an open ear to it. But again, I can't speak for a manufacturer, but in our experience and our conversations with them, they have probably a couple other priorities that they're trying to get to first before kind of changing or upsetting the apple cart on making sure that panel is durable.
We just got a related question, I think one that's perfect for kind of what we see on screen here. So I'll turn this one to you, Brett. This is from Caitlin. What's the common hang up between incomplete recycling, so this middle bar in the chart we're looking at, and true panel recycling, or the rightmost bar? So what components or materials might be left out? Kind of what distinguishes these three categories that we're looking at?
Yeah, absolutely. So landfill disposal is pretty straightforward, right? You have your tipping fee and your transportation to get it there. So that's typically going to be the lowest. There's obviously a range if you're in an area that's quite a bit of population and their landfills are coming to capacity. Their tipping fees might be quite high, where recycling is already lower than that. But landfill is pretty straightforward. Incomplete recycling is something that you'll see in a lot of different industries. It's when your major component, and we talked about this earlier, is the low value item. So glass is a low value item. In fact, in the United States, it's a negative valued item. By the time you transport it to your facility, get clean commodity separation, and sell it into a manufacturer, the value of it does not exceed it, those costs. So it's really a negative valued item. So why does it open up the world of incomplete recycling? You might see other recyclers call it sham recycling. Is the easiest part to recover is the aluminum, right? You don't really need a whole lot of technology from it. You could really just manually remove it. And then you have this item that's sellable, but that's 10-15% of it. So incomplete recycling is when someone could offer really any price, right? We even put $0 in this example. If they know there's some value in low-hanging fruit in the aluminum, to go capture it, and then they'll capture that, and the other 90% could go to landfill, get shredded and commingled. So that's what you kind of will see in the world of incomplete recycling is, let's get this low-hanging fruit that isn't a large percentage and just be done with the rest. It doesn't require technology, investment, R&D, or advancement there. True solar panel recycling is when you could separate those items to all of those commodities so they could all be introduced back into different manufacturing streams. That's true circularity. There's obviously major benefits for that. We don't have infinite amount of resources in the world, right? So demand for solar stays the way it's been rising, year over year. It's important to capture those and at least get them back into solar, the products that can be, or other manufacturing streams.
And we've also got this big number here on the right, cost reduction in the last 3 years, costs coming down by about half. Is this in regard to true panel recycling specifically, Brett? And if so, kind of what goes into that cost calculus?
Yeah, absolutely. So that's an SPR stat. So obviously we can't speak for, other true recyclers and what their cost structure has been. But the part that I can speak about that's kind of industry wide is it's opportunity costs and economic, or the economics of scale, right? So you're not going to realize economies of scale when 80% of the panels in the United States that are hitting end of life are going into a landfill. But when SPR opens up more facilities, and we've done several million panels between our facilities, and other recyclers are actually getting clean commodity separation, investing in technology. Well, now these final products, now there's a glass product that has certain characteristics that the SPRs of the world and other recyclers could go to market. And now maybe a new manufacturer would consider using this recycling glass, call it, because there's enough for it. But it's hard to go to a market and say, hey, we have this this glass or this aluminum or this silicon that we hope you could consume in your manufacturing. And then they go, okay, can you provide, 25 truckloads of that a month or whatever that may be, right? So a large part of the cost decrease is new opportunities opening up to consume the final product. And then the other major portion of that is the technology side of it. We've gotten faster, we've gotten cleaner. We have 4 different technologies in our portfolio. We'll talk about one today because it's a pretty common one used both domestically and abroad. And some of the other ones are, still a little bit more on the proprietary side that maybe some of our clients will only see. But that's really what's driving cost decreases, opportunities for different manufacturing industries that consume the product, and technology bringing the cost to actually recycle down.
Well, let's just go right into it then, Brett. And so these are all photos that you had provided, and just taking a look at kind of what that true recycling process means to you, what it looks like in your facilities. You want to just kind of walk us through your process and maybe what some of the things are that we're looking at on screen?
Yeah, absolutely. We're willing to share this technology because recyclers we visited in Europe, Asia, even some of our competitors that we have a good working relationship with, most of them will have some portion of a mechanical way of recycling. So, there's not a whole lot of proprietary. Everyone might have a little bit of a bend to it on how they accomplish it. But, ultimately in this particular technology, what you're going to see is mostly mechanical. It's low power consumption. It doesn't have to utilize chemicals. It doesn't have to utilize thermal or heat for air emissions. And it doesn't have to utilize water. So it is one of the preferable ways in terms of being green. So we ultimately load the panel, and we have a couple different technologies depending on what plant you're at. The top left one is our North Carolina plant. It's a AI camera that will read the length, the depth, the width of the panel, where the junction boxes are at. And it kind of speaks to the rest of the automated machine. And we'll talk about that a little bit later. The one to the second photo there is actually out of one of our Texas plants. That is a 3D mapping loading area we have. And what we're utilizing there is we're making a database. So when you go 3 months down the road, 9 months down the road, 5 years on the road, when we're going to market, and Justin might call us up and say, hey, we're decomming 90,000 panels of this make and model. We would like to have this database that we already have all the stats. We know how many we could recycle in an hour. We know what our recovery rates are. So that's what we're doing there. Ultimately, the junction box gets mechanically removed. That's 100% recyclable. It's similar to, the e-waste world. You have plastic, different metals, nickel, copper in it. Then you remove the aluminum frame. Aluminum frame could go direct to different foundries in the United States. So that could go back into solar. We'll talk a little bit about how supply chain works in the recycling world, but we can't go to a large aluminum foundry and tell them that our product we're feeding them has to go into a certain product, right? They're taking large contracts and manufacturers, but a lot of the aluminum from solar recycling does indeed go back into solar. So we remove the junction box and aluminum at this point. And then we have a specific laser that will remove the kind of the border adhesive. We only have to do it on certain makes and models. One thing that's wild about the solar world, now that we've done several million panels through our facilities, you might have the exact same make and model panel, but it was manufactured slightly different. There's a real rush to meet demand, right? So the same make and model might have a slight difference in the bezel or use twice the amount of glue as the first batch they ran. So sometimes to get cleaner glass separation, we will remove that little glue strip, if you will, ahead of the glass being mechanically removed. We could utilize things such as pressure rollers or milling to get it off the glass. We then screen it into different cullet sizes depending on what our consumer is ordering at the time. So now we've removed frame junction box glass. So now we are left with the silicon sheet that contains the metals. We shred it down. And then again, what's kind of common, throughout the world on this mechanical process is you're going to use some sort of density separator, kind of like an internal cyclone. It's going to suck out the lightest material, drop out the heaviest. And then we use some, electrostatic technology to separate out the trace metals at the end. So at the very end of this thing, we're getting plastic, silver silicon mix, copper, our glass in different cullet sizes, our aluminum in our junction box.
That was great. Thank you. And you alluded to this, Brett, and just want to dig into it a little bit more, but like the overall supply chain. So, let's say Justin ships you guys 90,000 modules. You go through the entire true recycling process and you're left with the materials you just walked through. So silicon, plastic, aluminum, et cetera. What happens next? Do you have a set group of customers who come to you and say, hey, I need aluminum, I need glass? Do you put them out into the market? Are there specific solar manufacturers you're working with? Like, what's that final step to make this really circular?
Right. So circular, depending on who you ask, could be, in my views, coming from the recycling world my entire life, the importance of it being just in solar isn't as important, right? We want it to go into any manufacturing stream that could consume it, get it back into a new product, make a new product, and then let that circularity ball keep rolling. But so there's a mixture of both, right? So we do, the industry is getting known enough and enough press releases and trade shows that you do have some manufacturers reaching out to us and saying, hey, you're one of the thought leaders and market leaders in the country, you're generating some volume, I'm assuming, tell us about your glass cullet, tell us about your aluminum you're recovering. And then again, normally it goes into some sort of lab work to understand the true composition of it. And then you could start making products. But a lot of it is the other way as well. We have a team, we have a circularity analysis here, and it's Finley Collins, and she'll reach out as well. Hey, I see, as a manufacturer, you have a goal to use 20% recycled material, 50% recycled material. I think our output could fit it. And then again, it goes into the lab testing and things of that nature to see if it could work. So it's a little bit of a push and pull in terms of making it circular. The big challenge with glass recycling being used back into solar in the United States is glass manufacturing in the United States. It uses float glass. It's much less energy intensive. So there's a lot of float glass set up. But antimony, which is a metal in most glass cullet, cannot be used in float glass processes. So it has to be in a roll glass process. So in European and Asian markets, that glass cullet actually could be recycled into new solar panel glass. In the United States, that's a challenge that many glass manufacturers, recyclers, and even solar manufacturers are trying to tackle.
Last one for you on the process here, Brett, and we actually got a handful of pre-submitted questions all on the same topic. I'm going to credit Alex Haney for being the first to submit this question. But just really a confirmation that if the modules are broken or damaged, it doesn't have a major impact on recyclability. You know, a hailstorm smashes the glass on 1,000 modules. Is that going to impact your process at all?
It can impact the process, but it doesn't mean that they're not recyclable. It's why we have kept adding different technologies to our portfolio. And we only shared one of the mechanical ones today. There's some other cool things we're doing that at the moment we think we're a bit ahead of the curve on, so we're not, quite willing to share those, publicly to the world. But yeah, so different panels, even let's take a step back, even panels that haven't been damaged by a hail or are broken, certain panels do better with a different type of recycling technology, whether it's due to their size, whether it's due to them being bifacial glass instead of single-sided glass, whether it's due to them not having a back sheet, whether it's due to them being cadmium telluride. So there's different technologies that could achieve higher recycling percentages. But for the most part, them being, hail damage or storm damage, it doesn't really affect the ability for it to be recycled. The only time you've seen it, and it's a little bit rare, where our recycling rates might have dropped from like a 99% or lower. We did do a large storm when Hurricane Helene spawned. A lot of tornadoes during that hurricane in the southeast. There were some farms that the hurricane or the tornado that spawned from that hurricane, you could literally see how it etched out the path in the farm. So some of that product, when it was hitting the recycling stream, was just completely twisted up and mangled, and there might have been dirt and debris and non-solar, components in it. So some of those like more outlier situations, it could be a bit more challenging.
Sure, sure. Well, I've got one more for both of you, and then we'll move on. And this one, we had pre-planned it. We've got a couple kind of questions and comments here already, mentioning this, but just the importance of making this recycling service more visible to the industry, increasing awareness, and countering misinformation on the other side of that. And so I want to open this up to both of you, Brett and Justin, just if there's any, especially poignant misinformation that you've seen, like what's out there that you see most often? What are the myths that you have to dispel with your clients around recycling?
Go ahead, Brett, if you like.
Sure. Yeah. We'll start with the most basic one is, solar panels can't be recycled, right? That's common. If you pull up LinkedIn, comments or any, you get in the weeds in any social media, there's a lot of solar opponents out there. We're all aware of that. So they're always looking for that new topic to latch on why solar shouldn't be installed. And a common one we see when there is a hailstorm that they, might get national attention, in Texas. Everyone's seen that site before. You can just see thousands of comments. Well, they're not recyclable. And these panels are gonna, really be a harm to our local community. So yeah, that's misinformation. They are recyclable. There's already recyclers like us right here in the United States doing it. So that's a big piece of misinformation that we have to still debunk. And the other side to it, we've already hit on it, so I won't spend too much time on it. But all recyclers are the same. It's absolutely not the truth. If you are going to follow certain local and state regulations that are starting to go into place, or if you're getting ahead of the curve, you're doing the right thing, you want to have proper ESG reporting. Some recyclers have outsourced methods where they bring it in, but they're actually not getting all this commodity separation. So then it starts going to different chains and you kind of lose control and visibility of it. We talked about incomplete recycling. There's an ability ahead of it being highly certified or highly regulated for greenwashing, if you will. Hey, we're a recycler, and at the end of the day, they're out to get to aluminum.
Yeah, and I would echo that as well, especially with you can't recycle the solar panels. I hear that quite a bit. But from the decommissioning side, I think it's more of a lack of information, especially when there's like an asset owner that buys or takes over a field that's already there, and they don't realize that there's a decommissioning component to that and disposal component of that. they don't factor that cost in up front. So that's
Justin, I'd be curious, since you're definitely on a step ahead of us here on the decom side to enters the recycling space, but we'll be at trade shows, mostly domestically and even sometimes abroad, where someone's in that permitting stage to get a new site up, and they have this misinformation that when this site does get decom, there's so much value in the wiring on site and the racking that it could cover all of the costs of transportation and heavy equipment and returning sites back to their original state to an extent where they're putting it as a value to try to, lower whether it's insurance or bonding. I'm sure, I'm
yeah,
wondering if you came across that as
that's a
well.
major that's a major component that we hear a lot, that the salvage cost should cover the whole cost of the decommission and everything, and that is definitely not true, especially in our experience. And we've done quite a couple dozen of these things, and it never turns out that way. Some sites have a little bit more scrap value, but there are certain ones that are built, could be even twice the size of the smaller one that's more valuable, and it really doesn't have any value whatsoever. So yeah, definitely misinformation there.
Yeah, and let's actually take a look at that. So next up, we've got kind of just walking through specifically the decommissioning portion of this. And now we're kind of upstream of recycling, but Justin's team's on site. What happens next? What is that handoff point then, Justin, from your team to Brett's? And what do folks need to know who this might be new to them?
Yeah, let me back up a little bit in this process. So the majority of the time, this happens at some asset owner or utility. There may be a project manager that gets tasked with getting this system removed and recycled. From that point, I've been there. I've been on that side of it as well as a project manager. You kind of think, the recycler handles everything. Kind of going back to that misinformation, you might want to contact the recycler first. Well, they may not have a team that actually does decommissioning, but all they do is recycling. So then you got to figure out who can do the recycling or do the decommissioning. That's where we get involved. From that point, there could be multiple stakeholders that we have to interface with, whether that's the project manager, the legal team of that utility. I know one we just recently did was at a manufacturing facility. Now we're dealing with the manufacturing facility's plant manager, and then their legal team to ensure that the lease has been fulfilled and they've been paid for all of the terms of the lease. Then that utilities legal team has to get involved. We're dealing with getting our equipment out there, coordinating with Brett, really having those planning meetings up front with all the stakeholders to ensure we're all on the same page for when we start. Once we get set up, we're starting to decommission. We've already got Brett's team lined up, and he's sending the trucks in to pick up the panels. From the point that we loaded on the truck and signed over that custody, that's where our scope kind of ends and Brett's begins. And then if it ends up being where we have to get the logistics for the trucking and everything, once we get it to Brett's facility and at the dock, and we sign it over, that's where our scope would end in that case.
And are there any, I mean, in your experience, Justin, are there any kind of lessons learned, any projects where you came out of it and you're like, well, we're going to have to change our process a little bit, and just actionable kind of suggestions for anyone who might be here who's also in the decommissioner
Yeah,
role?
definitely. The very beginning, of course, first projects like we ever worked with Brett on, you have your little hiccups. Nothing major. You get better each time, but it really goes back to the original planning of events and the scheduling, and ensure you stay on schedule. One of the other lessons learned would be make sure you document and take pictures of your site, and do a good walk down with the site owner to ensure all your as found is documented correctly. We had a lesson learned once where a parking lot had just been paved at the facility that we were going to take the system off of, and we did the walk down, And right when we first started and pulled our trucks onto the lot, the pavement started to sink. We had to note that, and they didn't really pay attention. And towards the end of the job, they tried to point fingers and say it was our fault, our trucks were too heavy, all that. And it was just happening with like a normal F-150 pickup. So we were able to show, hey, this was poured wrong. There could be many instances where they're like on a roof or something, and you make sure you document all that up front so it doesn't come back to bite you.
And in the spirit of the logistics portion of this webinar, the more planning and vetting and a true program and partner you can get in place on the decom and recycling side ahead of these panels, coming off of their racks, there's this major upsides in cost savings. What we've seen, probably more times than not, actually, from some of our, larger projects that might be 100,000 panels, 500,000 panels. We have a million panel project going on at the moment. Is there wasn't a lot of planning or conversation with the recycler ahead of these things getting removed off the rack. So they might have already paid, whether it's that new company putting on the new panels, to palletize them somewhere on this site, and they might only have palletized them 25 high. So now they're loading truckloads at 18,000 pounds when you have up to about 44,000 pounds capacity. So you almost have a 3 times multiplier in transportation costs. So you go back and say, hey, if you could get them stacked this way, we can maximize every pound or at times space in a truck to maximize it. And, if on these large projects, that could be millions of dollars of savings. It's unbelievable. So, really getting ahead of the curve and turning this into a true partner and program is important. This isn't just a haul away service or, hey, we have this trash here, come get it type deal. There's so much that could be done on the front end to really keep costs lower.
Yeah, I think that's definitely a theme that we're seeing at Mayfield in these last few years, is as we've really leaned into commercial scale in particular, is the more you do up front, the more savings you see later on. And that's really in all respects of development, decommissioning, end of life considerations. It may seem like a lot up front, but it makes everything else so much smoother. And I think that's one of the takeaways from this conversation here today. One other thing we wanted to just quickly talk about, since we haven't mentioned it at all thus far, is what happens to everything other than the modules. So there's a lot of balance of system equipment here when we're decommissioning. Alternatives to both of you, open-ended, but wires, combiner boxes, batteries, you name it. Kind of what's happening beyond the modules for decommissioning and then recycling.
Yeah, so it can be racking, inverters, transformers. We've recycled or disposed of all, but that a lot of that has to go back in that planning phase and find out who owns that. What is the actual direction? Does the site owner want to keep that? Do they want to use it at another site? They own all the scrap. Is that used as part of, as we price these jobs out? Do we get the scrap, or does the owner get the scrap? So there's a lot that goes into there, but anything that can be recycled will be, and if not, we have partners for salvage, usually in most any area that we're working in.
We got a couple questions here. I want to maybe pull you in here on this one, Brett. This one's from Gregory, but could you provide an example or speak to the customized recycling program and what that might entail?
Yeah, absolutely. We just started getting into it a little bit, but there's really not a lot of sites that are just a rinse and repeat type program, right? We've had sites where some of the racking and panels were put over an old landfill, so we couldn't bring regular heavy equipment on site. I had to have a certain PSI tires and rated tires and weights. And then again, we've had programs that will say, hey, we need it all the way from removing the panel from the rack, where we bring in someone like Justin, or hey, we've already had these things kind of, accumulating in this certain portion of our solar sites. So we simply need someone to come in and palletize them, band them, maximize trucks. Then we have ones where it's, hey, they're all are palletized and banded. We don't have the ability to load it. So I just bring in equipment to load them. And we have some where it's just back in the truck and we'll take it from there. So customization has everything to do with what services are needed on site. How do we do this most efficiently? There's been times where we've had vendors want to hire us to do the decom side or you find someone like Justin to do that side just to find out that they were able to leverage that, maybe in the company putting in the new panels, things of that nature. So the customization side really has to do with, let's take a look at what are our routes in and out of your site? How are we going to load on your site? Is there room to store? All right, as they're coming down, is there only room to get 2 trucks in, stage 2 trucks at a time? So we got to make sure that logistics plan is on point, because once you have 2 trucks of panels staged, it kind of could stop the repower dead in its tracks. So there's just so many nuances that go into it, where we can look at it and find the best way to be efficient, the best way to minimize costs, and again, the compliance side of it, right? So there's a whole nother compliance piece of this. I know there's a question on here as well, pertaining to that, but where are they getting transported to? What are the regulations and transported if you don't have T-clip testing? All sorts of items to really make sure that specific asset owner might have sites in different states. So, right. So what we're doing in one state for the same client might be completely different than another state. So that's really what we mean by the customized recycling program.
Yeah, and speaking of differences across the states, I think that's a great kind of transition point here. We've also got a couple questions on the policy side. So William asks, where are we on the policy level for requirements for true solar panel recycling? What's in it for the EPCs who may not have time to manage this in a shifting market? Do you anticipate more of a stick or carrot approach when it comes to recycling? And are inverters typically recycled as well? So a lot to chew on there, but I'll toss it to both of you guys.
Yeah, I'll try to be somewhat brief since we're getting up against the hour here. So I'll first and foremost give a shout out to North Carolina Clean Energy Technology Center. So for everyone, listen, that wants to look up this report, it's North Carolina Clean Energy Tech Center. They do a report each year. They call it the 50 States of Solar Decommissioning. And they really do a deep dive of staying up with the ever-changing policy shifts. A lot of the policy shifts could be at the local level, the state level. There's some federal level ones that come into play in certain sides of this. We have an in-house compliance team at SPR. So again, I think having a true partner and not just calling someone and saying, hey, what's the cheapest price to get these panels off of our site, could really have big savings at the end. So for EPCs that might not have time to kind of keep up with the ever-changing landscape of regulations, having a real partner that has a grasp on that could be very helpful. Again, we just talked about it in the customized recycling side of things, is that we can look there. A lot of the major asset owners in the country we've already have met with in conversations on, here's all of our sites, here's the ones that might be having a repower soon, here's ones that might be in an area that could have a weather event at any time, and we really already have a plan laid out for them to make sure that it's ticking all those compliance boxes. A brief overview on the policy level. Texas went active in September 1st of 2025. It passed the House and Senate in Texas and has already been signed into law. They have an outright ban on landfilling panels, so they're encouraging recycling. North Carolina, if it's 2 megawatts or larger, has legislation in that you have to have a decommissioning and true recycling plan in place. That's even retroactive. There's a time frame for sites that are already operating to get that in. And then, a lot of states might have some different requirements at the local and state level. Most of the time in the recycling world, regulations will really be driven by the state level.
Anything to add there from your experience, Justin?
No, I think Brett summed it up really well.
Yeah. Okay. We got kind of a follow-up here from William, and it sounds like he does work in New York State. And so he's asking about places where real estate's prohibitively expensive. Nearest plants might be a couple states over. So that maybe the shipping logistics become more expensive, a little bit more complex. How do you guys handle those situations?
Yeah, from the recycling side, the challenging part is this isn't an industry that's your local tire changing spot where you're going to have options in every city or even every state, right? Even if you look at electronics recycling industry, there's quite a bit of electronics recyclers nationally. It's been an established market for 3 or 4 decades, highly regulated. You still might not have an option in each state for someone that can meet your needs. So if you're looking at the recycle market that's in its infancy stages, you many times have to go several states over. What we're doing at SPR, and you can kind of see it on that map there, is we have 4 recycling centers that is servicing the country. We're currently working on where we're going to be even further out west and should have that plant, going in 2026. And what's really important to note is these are actually owned and operated. We're recycling in-house with no outsourcing. And these aren't just consolidation plants that, hey, we're just going to collect panels here to eventually get them to another site because those present risks in itself. If what happens if that recycler goes away, who's liable for those panels that were left behind?
Well, the questions are pouring in. We've got just a couple minutes left, so I'm just gonna have us land here, key takeaways really quick, and then we'll wrap up with as many questions as we have time for. We've really reinforced, I think, all 3 of these throughout the hour. So establishing clear plans is always a best practice in all respects, particularly with decommissioning and end of life considerations. Beware of misinformation. Hopefully, we've dispelled a few of those myths here today, but if not, we will have Brett's contact information on screen. You can always get in touch with SPR. And then, as we just looked at, some regulations are already in place in certain markets like Texas and North Carolina, and in many others, those are soon to come. So be aware of what's in your region. Use the resources that Brett's team is providing to stay up to date on what's available, and then take advantage of them as you can. I'll leave some contact info on screen here. This is for both of our speakers. If anyone wants to get in touch with any questions, I do just have a couple more that I want to toss out to you guys, though, just in these last few minutes. First one, kind of open-ended. I'll maybe tee you up here, Justin, but as much as planning ahead is great, can be hard to predict what the industry looks like 10, 15 years in the future with regard to recycling and decommissioning. Any suggestions for currently planned installs that could anticipate those changes? Like, how are you baking this into your development roadmap, your contracts, Justin, when we're really looking a decade into the future?
Yeah, so there's something called an asset retirement obligation. Usually, if most companies use that, they're able to get kind of what that predicted cost is in today's dollars, what that would look like, and that should be updated every year. But really getting in on the front end of what that looks like from a decommissioning standpoint, recycling, you can look at all the developments that have been put in, the solar sites that have been placed in service over the last 15 years. You follow that curve. We already got the data earlier of that 10 to 15 year plan. That's just a lagging curve right behind it. So this is still going to continue to become more of a conversation and a thought that needs to happen on the front end. So yeah, definitely it goes back to again the whole planning thing, right? Make sure you're ready for that when it comes, so you don't get hit with any surprises.
I think we have time for one more. I'll leave this one for you, Brett. This comes from William. Do you think there will be firms that collect from multiple panels, like aggregators or traders, and then go over state borders for recycling purposes? At what point does our solar recycling industry become profitable for the recycling party that brings the panels to the facilities?
Yeah. So aggregating and kind of consolidating, for the most part, you're getting about 500 in a full truckload. So in the grand scheme of things, that's not a whole lot. So the opportunities to really do a type of, consolidation and trade or partner with the recycler is probably going to really be in the residential space where, an installer has 30 here, 15 here, and you could get that full truckload. for the most part, the larger projects, they're at least 500 plus panels, right? So you're just talking about how many truckloads I have and where am I going to send them to? And it's a little bit of what comes first, the chicken or the egg, right? How many of us are going to invest in the R&D and the technology and getting facilities up and getting permitted ahead of having way more solar panels hitting a recycling stream versus landfilling. So regulations, support of state senators and legislators and those environmental committees and review boards in all of these states, all of those major players advocating recycling will help more and more recyclers enter each state. We'd love to have a recycling in all 50 states, but I think our ROI on that would be a huge risk at the moment until there's more recycling being done in the US.
Great. Well, we'll have to do another one of these in a couple of years, and we'll get some updates from both of you guys. Well, we are at the top of the hour. Really want to thank you both, Justin, Brett. Thank you so much for your time, your expertise, and thanks to everyone for tuning in. We will send a copy of this recording to everyone who registered, and a bit of information on our episode next month on repowering. So we'll be talking a little bit about recycling next month as well, and hope to see everyone there.
Thanks, Lucas.
Thanks, Lucas.
Thanks all.